Mayroon na naman tayong bagong project. Ano na naman yan? Ito ang bago nating project. Nakikita mo ba ito? Ay, syempre naman. Ano yan? Magmamagic ako. Ito na. Ha? Gamitan natin ang supply na 9 volts. Ano magic na naman yan? Hop! Yan ang bago kong magic. Yan ang tinatawag na breathing LED. Makikita mo dyan yung LED parang humihinga. Diba? Oh. Simpleng-simple naman yung magic mong yan. Aba? Ayan o. Oh. Diba? Magic yan. Nag-on off yung LED. Unti-unting nabubuhay, lumiliwanag, and then dumidilim. Yan ang aking magic. Walang kwenta na naman yung magic mong yan. Ha? Ayaw mo yan? Oh. Ang gamit ko dito. Oh. Yun oh. Op amps. LM358 Dual Comparator op amps. Nakagawa ako ng magic. Diba? Let us now see the circuit diagram of our project. Breathing LED fader LM358P op amps dual comparator. Okay, this is the circuit we use in our project. We are using 9 volt supply to the circuit, and then we also use a lot of resistor and also transistor 2N3904 BJT with LED red. And also we are using capacitor 10 microfarad 25 volts, and then we are using these two LM358P op amps or comparator. Actually, this two comparator, it is considered as dual comparator because of in the package we have this LM358P pin out. It composed of two op amps or comparator. Pin 1 is the output, pin 2 input of inverting, pin 3 input of non-inverting, pin 4 that is the ground or the negative voltage, pin 5 input 2 of another comparator non-inverting, in pin number 6 input 2 inverting, pin number 7 the output of the second comparator. Since in this package, dual inline package or in IC, this is 8 pins consisting of two comparator. That's why they call it dual comparator. And the IC is called LM358P IC, consisting of two comparator. That's why in our circuit we are using only one IC that that has two comparator or dual comparator inside the IC. To understand the operation of the circuit, we're going to refer to the figure number 2 block diagram of the circuit to simplify the operation, the workings of the circuit. So we have this 9 volts, the supply, and then the first circuit is an oscillator, and then after the oscillator there is a fader circuit, which is responsible for the turning on and off the LED gradually, or little by little it turns on and off. Okay, so in the first circuit we have this oscillator. This oscillator is the one responsible for making a pulses, square wave. Okay, it is capable of producing a square wave, this oscillator, on off. That is going to be fed to supply to the, we're going to supply the square wave to the fader, or the next circuit fader, and the fader is responsible for making this LED to turn on and off. Okay, where is the oscillator in the circuit? Okay, now here is the oscillator. This is the oscillator. Okay, and the output, you can see here the output is connected to the LED. So transistor, then LED. So this one is the oscillator. Why is it an oscillator? It is capable of producing square wave pulses, turning on and off. Because here we are using a single supply power rail of the op-amps. It means a single supply. We're not using a dual supply, single supply. How is it possible that we're using a single supply? Because of the voltage divider. Creating a voltage divider to the pin number 6. This is now the virtual ground. Making this pin number 6, if this is 9 volts, half of the voltage, 4.5 volts, and the other one, that is 4.5 volts. So we're creating an offset. There is a positive and negative voltage into the circuit with an offset. Also into the other comparator, we're using the divider connected to the pin number 3. Since it is connected to inverting, the other one is connected to the non-inverting. How is it possible to oscillate? Because of the capacitor. The charging and discharging of the capacitor, that will make this op-amps to oscillate. As you can see here, the output is connected to the input of the another comparator, and the output of another comparator is connected to the input of this another comparator. So they're capable of oscillation, making an oscillation. And this capacitor is responsible for making the LED to turn on and off, dimming, or we call that dimming of LED because of the charging and discharging of capacitor. It looks like an integrator, because an integrator is capable of producing a triangular wave. This square wave is converted into a triangular wave, because in a triangular wave, the characteristic of the light of the LED is it is charging the capacitor, gradual charging of the capacitor, and then discharging, charging, discharging, charging, discharging. That is the graph or the waveform of the dimming capacitor or breathing LED. That's why it is a breathing LED due to this circuit. The capacitor is what's responsible for the oscillation. It's always when we have this offset voltage. When I said offset voltage, in an XY axis, our reference, usually the ground is 0, right? And then since we are using only one supply, we create a virtual ground, producing an offset from 0 to this virtual ground. They call it an offset voltage, which is 4.5 volts above the ground. The other one, 4.5 volts. So this is now the virtual ground, making an offset. So there's a swing of a signal between positive rail and negative rail, negative 4.5 volts of the op-amps because of the offset. Okay, the signal swings from positive and then to negative, positive to negative. That's why we are using a single supply, a virtual ground, the same comparator. So because of due to the oscillation, and it is converted by this fader. This is some sort of an integrator. It integrates the digital or this on and off pulses. By using calculus, you can derive the triangular waveform. But we are not doing calculus here. We're just analyzing the circuit. And then with this type of transistor, it is the output is connected to the emitter, which means when we are referring to this transistors here is served as a switch, at the same time a driver and amplifier. Okay, the output connected to the emitter, and then we considered is as a low side switching. If the output is connected to the collector to the power supply, it is high side switching. But here it is a low side switching because the output is sinking and the transistor is in the source side, sourcing and then sinking. But when we are going to compare or we're going to use an op-amp referring to the transistor, the use of transistor here is as a driver. It helps to make an output to make the output or the current of the LED that will produce a constant current source. Because we have this transistor, it will produce a constant current source. And the configuration now of the op-amps referring to the transistor, the op-amps is sourcing current and the transistor is sinking current. At the same time, this serves as a driver that will produce can help to produce a constant current source. Okay, we have this variable resistor 100K. It is capable of increasing the dimming of the LED. We can increase the dimming or the on and off the LED. We can make it faster or slower by turning this trimmer. We are using a trimmer between the two 15K. Here we have 100K feedback resistor, of course, and then 10 microfarad, 25 volts, 47K, R1, R5, 470 ohms for the current limiting value of our output LED red. Okay. So what makes this comparator to oscillate? Due to the charging and discharging capacitor. If this offset voltage is 4.5 volts, because this is 4.5 volts to the pin number 6, it is now going to make this another pin number 5, to balance the voltage. So it is charging up to 4.5 volts, because the role of op-amps is always equalizing or balancing the input. Same as here, it is always, because it connected also to the offset voltage. The role of the capacitor is to balance the input, also the feedback, positive feedback, referring to the oscillation. When it is positive feedback, it means it is an oscillator. And a negative feedback, where is the negative feedback? Here, referring to the some sort of amplification. If this is an oscillator, since we don't have any input signal, it can oscillate due to the amplification of the internal noise inside the op-amps. That's why we produce these digital pulses, or on and off, due to the amplification of this internal noise inside the comparator. That's why we have this oscillator. It amplifies and oscillates at the same time. It oscillates. We are going to connect the LED to pin number 7 to test the oscillator OSC pin number 2. And then we also have this LED fader, the signal pin, connected to the LED module. This is the fader. And this one is the oscillator. You can interchange the two. This is our new module. The fader. And then this is the module I built last project. So in our module, we can use the oscillator output and then the fader or the breathing LED. Because our module has 4 pins. One for oscillator, one for LED breathing circuit, and then for power and the ground.